Welcome to our video lesson on types of chemical reactions. In this lesson, we will explore different types of reactions and understand how atoms bond and rearrange to form new substances. As we learned, during a chemical reaction, atoms of one element do not change into those of another element. Instead, chemical reactions involve the breaking and making of bonds between atoms to produce new substances. Let's begin with the first type of chemical reaction known as a combination reaction. In activity 1.4, we observed a combination reaction between calcium oxide, also known as quicklime, and water. As water was added to calcium oxide, a vigorous reaction occurred, releasing a large amount of heat and forming slaked lime or calcium hydroxide. Chemical equation: CaO plus H2O, L, right pointing arrow CaO, 2, Uk, plus heat. In this reaction, a single product, calcium hydroxide, is formed from two reactants. This is known as a combination reaction. Let's look at some more examples of combination reactions. The burning of coal, where carbon reacts with oxygen to form carbon dioxide, is a combination reaction. Chemical equation: C plus O2 grams right pointing arrow CO2, G. Another example is the formation of water from hydrogen gas and oxygen gas, where the two gases combine to produce water. Chemical equation: 2H2 grams plus O2 grams right pointing arrow 2H2O, L. In simple terms, a combination reaction occurs when two or more substances, such as elements or compounds, combine to form a single product. In activity 1.4, we also noticed that a large amount of heat was released during the reaction. Reactions in which heat is released along with the formation of products are called exothermic reactions. Some examples of exothermic reactions include the burning of natural gas, where methane reacts with oxygen to produce carbon dioxide and water, releasing heat in the process. Chemical equation: CH4 grams plus 2O2 grams right pointing arrow CO2 grams plus 2H2O, G. Another example is the process of respiration, where glucose combines with oxygen in our body cells to produce carbon dioxide, water, and energy. Chemical equation: hexacarbon-dodecahydride O6, Uk, plus 6O2, Uk, right pointing arrow 6CO2, Uk, plus 6H2O, L, plus energy. Now, let's explore the second type of chemical reaction known as a decomposition reaction. In activity 1.5, we observed a decomposition reaction involving ferrous sulfate crystals. When heated, the crystals lost water, changed color, and decomposed into ferric oxide, sulfur dioxide, and sulfur trioxide. Chemical equation: 2 iron 2 sulfate, S, right pointing arrow iron 3 oxide, S, plus SO2, G, plus SO3, G. In a decomposition reaction, a single reactant breaks down into simpler products. In this case, the ferrous sulfate crystals decomposed into ferric oxide, sulfur dioxide, and sulfur trioxide. Decomposition of calcium carbonate. Another important example of a decomposition reaction is the breakdown of calcium carbonate to form calcium oxide and carbon dioxide when heated. This reaction is widely used in various industries, including the manufacture of cement. Chemical equation: calcium carbonate, S, right pointing arrow CaOs plus CO2, G. When a decomposition reaction is carried out by heating, it is called thermal decomposition. Laboratory setup with lead nitrate powder. Let's move on to activity 1.6, where we will explore another decomposition reaction. By heating lead nitrate powder, we observed the emission of brown fumes, indicating the decomposition of lead nitrate into lead oxide, nitrogen dioxide, and oxygen. Chemical equation: 2 lead 1 nitrate 2, S, right pointing arrow 2 PbOs plus 4 NO2 grams plus O2, G. Decomposition reactions can occur due to various sources of energy such as heat, light, or electricity. In our previous examples, we observed decomposition reactions triggered by heat. Decomposition of silver chloride in sunlight. In activity 1.8, we witnessed the decomposition of silver chloride when exposed to sunlight. The white silver chloride turned gray as it decomposed into silver metal and chlorine gas. Chemical equation 2 add Cals plus sunlight right pointing arrow 2 Ags plus Cl 2 grams. These decomposition reactions are commonly used in black and white photography. Now, let's discuss another important aspect of chemical reactions, endothermic reactions. These are reactions that require energy in the form of heat, light, or electricity for the reactants to break down. Some examples of endothermic reactions include the process of photosynthesis in plants, where energy from sunlight is absorbed to convert carbon dioxide and water into glucose and oxygen. Chemical equation 6 CO2 grams plus 6 H2O, L, plus energy right pointing arrow C6 hydrogen oxide 6, UC, plus 6 O2, UC. Other examples include the evaporation of water, where heat energy is absorbed to convert liquid water into vapor, and the dissociation of ammonium chloride when it absorbs heat and breaks down into ammonia and hydrogen chloride gases. Chemical equation, NH4Cl plus heat right pointing arrow NH3 grams plus HCl, G. By understanding the different types of chemical reactions, we can better comprehend the transformations that occur when substances interact with one another. So far, we have covered combination reactions, where multiple reactants form a single product, and decomposition reactions, where a single reactant breaks down into simpler substances. We have also discussed exothermic reactions, which release heat, and endothermic reactions, which absorb energy. Chemical reactions are fascinating processes that shape the world around us. By studying the types of reactions and the energy involved, we can gain a deeper understanding of the fundamental principles of chemistry. That concludes our video lesson on types of chemical reactions. We hope you found it informative and enjoyable. Thank you for watching.
For more videos, stay tuned with us.